This tutorial outlines a process for optimizing vertex normals in 3ds Max, specifically addressing common issues that arise when preparing models for game engines. This example focuses on a tire mesh, which has been divided into three separate elements: the two sidewalls and the cylindrical tread surface. This separation is often based on smoothing group assignments, a crucial factor for performance within game engines. It's strongly recommended to maintain a single smoothing group per mesh element within your 3D model. Having multiple smoothing groups on a single element can negatively impact performance in a game engine, leading to unnecessary draw calls and shader complexity. Mesh elements are sometimes automatically separated during export, particularly when exporting to formats like FBX, DAE, and 3DS, and this separation can be based on UV map boundaries or surface normals. Therefore, ensuring correct smoothing group assignments within 3ds Max before exporting is a best practice. This minimizes unwanted separation and maintains performance. Select the entire tire object and apply the Unwrap UVW modifier. This is a temporary step to visualize the UV layout. As you can see, the UV map is organized into two primary chunks representing the sidewalls, and a more complex, often overlapping area representing the tread, the diagonal surface of the cylinder. The overlap is inherent to unwrapping cylindrical surfaces and is expected. Be aware that exporting to 3ds format often separates the mesh based on UV map boundaries, in addition to any smoothing group separations. This behavior isn't always desirable, so carefully consider your export format based on your game engine's requirements. Other formats might offer more control over how the mesh is separated. Once you understand the UV layout, now we can remove the Unwrap UVW modifier. It's no longer needed for this normalization process. The viewport's default, shaded with texture mode, can obscure the underlying surface normals. To better visualize them, switch the viewport display mode to clay. This mode uses color to represent the direction of the surface normals, making it easier to identify issues. Vertex normals are directional vectors associated with each vertex of a 3D mesh. They play a critical role in how light interacts with the surface, influencing reflections, specular highlights, and ambient occlusion. Incorrect or inconsistent normals can lead to visual artifacts like shading errors and visible seams. Examine the tire mesh closely in the clay mode. You'll likely observe seams or sharp edges where the separate elements meet. These seams are caused by the overlapping vertices at the boundaries between the sidewalls and the tread. Each vertex belonging to both elements has two or more normals pointing in slightly different directions, causing the light to reflect at different angles. This results in a visible seam. The goal is to unify these normals so that light reflects consistently across the seam, eliminating the visual break. This can be achieved by editing the vertex normals directly. Select the tire object and add the Edit Normals modifier. The default display length of the normal lines is often too long and cluttered. Reduce it to a more manageable value, such as 0.1. This makes it easier to see individual normals and their relationships. Each vertex has one or more lines representing its normals. Overlapped vertices will display multiple lines depending on the number of times the vertex is shared. The length of the line indicates the normal's magnitude, and the direction indicates its orientation. Under Average, click the Selected button. This merges the selected normals into a single direction, effectively averaging their orientations. The visual representation may appear as a single, but technically these are two overlapped lines representing unified normals data. Repeat this process for all overlapped vertex normals along the seams. This is the most time-consuming part of the process. To streamline the unification process, assign a hotkey to the Average Normals function. Go to Customize, then Customize User Interface. In the Groups tab, select Edit Normals. Locate average normals in the list and assign a convenient hotkey, for example, A. The vertex normal data applied through the Edit Normals modifier is stored within the Editable Poly geometry. This data will be lost if you add further modifiers that significantly alter the mesh topology after the normals have been edited, such as subdivision surfaces, Boolean operations. Therefore, it's strongly recommended to perform vertex normal editing as the final step in your modeling process before exporting your project. This minimizes the risk of losing your carefully adjusted normals. By systematically unifying the overlapping vertex normals, one can create a smoother shader across the entire mesh, eliminating visible seams and sharp edges between the individual elements. The mesh retains its separation into distinct components, each with a single smoothing group. This optimization significantly enhances the suitability of the tire mesh for the use in game development. Perhaps a script or tool within 3ds Max that could automatically identify and unify overlapping vertex normals based on proximity would drastically speed up this process. Ideally, 3ds Max would offer an export option to automatically unify normals during mesh separation, preserving the original orientation. This would eliminate the need for manual normalization in many cases. This functionality would be a significant time saver for game developers.